What is up, ladies and gentlemen, boys and girls? I hope all of you guys are doing good and your preparations are also going well for your term 1 examinations. It's right around the corner, guys. A couple of days, that's all, about 40 days to be precise. That's all you have. I hope you have already gone through the chapter at least once, because right now, guys, what we're going to do is we're going to start off with the Let's Revise series, where we're going to revise everything that we have learned in the past, because we know that it's been, we all understand that it's been a long time and there are chances that you have forgotten a couple of things. So we'll try to cover up those things in this couple of series that we have. So today is going to be the day we're going to revise about reflection and spherical mirrors. In the next session, we'll revise about spherical lenses. Then we'll try to do some numericals as well. And then we'll move on to human eye and colorful world. So that is a plan that we have for you guys. So make sure you subscribe to the channel, because I'm sure you guys definitely don't want to miss out on all these important topics. Now, in today's session, let me tell you what is the session plan basically. So I'm going to revise a couple of topics. Maybe let's say we'll start with plane mirrors and spherical mirrors, the basic stuff. Then I'm going to ask you a couple of quiz questions. What I want you guys to do is be honest to yourself and try to answer these questions with utmost conviction. All right. I don't want anyone to Google it. I don't want anyone to, take more time than what is necessary, because these questions are the same type of pattern that you see in your term 1 examinations. So keeping that in mind, we have put up these questions in between, you sprinkled it like how you sprinkle salt. Right? That's how we have done it. So make sure that you guys stay till the end, solve every question possible. And if there's any doubt that you feel like, sir, I'm really not clear about this concept, I might need a little bit more information about it, let me know that in the comment section. I'll read that up and we'll try to make out a video on that as well. All right. So yes, guys, welcome to the session once again. My name is Anoop. I am a master teacher of physics here at Vedantu. I am basically an aerospace engineer and I've been teaching for about 5 years now. And whatever I'm going to teach you today is going to be based on what we have done before in this channel. So if you haven't checked those videos out, you can definitely try those out as well. All right. So let's begin. All right. So here's the plan, guys. This is what we're going to do in the future. We'll understand about reflection and spherical mirrors. Then we'll understand about magnification and what is mirror formula. Then refraction and spherical lenses, lens formula, magnification and power of a lens. Super duper easy chapter this is. I know a lot of you guys are like, so what did you just say? Yeah, I said that. You heard that right, people. Yes, this is a very simple chapter. It requires a little bit, little bit of effort from your side. That's all. It is definitely not complicated. You just need to, give a little concentration, and trust me, it's like smooth as butter. All right, so let's begin. All right. So yes, guys, in this particular session, we'll understand what is reflection. We'll understand the laws of reflection. What are the types of mirrors? That is plane and spherical mirrors. Under spherical mirrors, we'll understand about concave and convex mirror. So that is basically the session plan, right? So yes, let's start with what is reflection. In simple words, guys, reflection is nothing but the bouncing back of ray of light into the same medium by an object. That is what is called as reflection. What is it? It is nothing but the bouncing of ray of light. Can you see this? A ray of light is coming and falling on a mirror. It gets bounced from that mirror and is sent back into the same medium. That is what is called as reflection. Now, the ray of light that is coming and falling would be termed as the incident ray, because obviously, how would you differentiate? So that is why we call it as an incident ray. And the ray of light that is getting reflected back, we will call it as a reflected ray. Again, how would you differentiate if you did not have names? So that's why. All right. Now, apart from that, guys, you also have to understand that there is something called as a normal. Normal is nothing but a straight line perpendicular to the surface. So if this is my mirror, it's a straight line. So if this is my mirror, a normal would be nothing but a perpendicular line. In other words, it's a line which is making an angle of 90 degrees to the surface. That is what is called as a normal. So wherever the light ray is incidenting, to that point, I'm going to draw a normal. And this angle that is formed between the incident ray and the normal would be called as the angle of incidence. And the angle formed between the reflected ray and the normal would be called as angle of reflection. I understand. My drawings are next level. You can let me know in the comment section how good it was. All right, later. Now, let's get back to the topic. Now, guys, the thing about plane mirrors is that you've already studied this in your lower grades. I don't have to say much about it because you've already studied this for a very, very long time. But just a quick revision, guys. Plane mirrors basically are mirrors which has infinite focal length or infinite center of curvature. And here what you see is that no matter where the object is, the image will be formed at the same distance from that of the mirror. So if the object is, let's say, about 5 meters from the mirror, the image will also be 5 meters away. And apart from that, one more additional thing is that the size of the object and size of the image would also remain the same in the case of a plane mirror. Now, if you talk about the image properties formed by a plane mirror, the image properties you have to remember is that it's always virtual in nature. The image is always virtual. Virtual means those images that cannot be caught on a screen. Any image that cannot be caught on a screen is called as a virtual image. So here you can see this. No, the image is formed behind the mirror. It's formed behind the mirror. So tell me this, people, if the image is formed behind the mirror, can you take a sheet of paper, or let's say a white sheet, a white, what do you call that as? Those things that you see, projectors, those projectors would have a screen. Yes, white screen. So imagine you have a white screen. Would you be able to capture this image if you were to place a white screen behind the mirror? Would you guys be able to do that? Obviously not, right? It doesn't make sense at all, because in the case of a mirror, light is not allowed to pass through it. So obviously there'll be no image caught in that. So that type of image is called as a virtual image. Any image that cannot be caught on a screen would be called as a virtual image. Simple as that. All right. So the image over here in a plane mirror is always virtual. Now remember, guys, virtual image, any image that is virtual in nature, is always going to be erect as well. All right, it's like a beautiful love story, like Jack and the other girl who killed Jack in Titanic movie. What's her name? Rose. Yes. Yeah. So yeah, it's like Jack and Rose. Like, they're always, it's always together. They're never separated. They're always, they're like this old couple, old beautiful couple there. Virtual images are always erect in nature, and real images are always inverted in nature. Again, they are also like a beautiful little old couple. All right, so this is a kind of jodi that never breaks. All right, all virtual images are erect in nature, all real images are inverted in nature. So in a plane mirror, it's always virtual, which means that it's always going to be erect as well, and it's going to be of the same size and same distance, right? And you also see something called as lateral inversion, which is nothing but when you're standing in front of a plane mirror. Have you ever noticed this? When you raise up your right hand, it looks as though you're raising up your left hand. When you raise up your left hand, it looks as though you're raising up your right hand, right? So this is called as lateral inversion. So that is another property in the case of, plane mirrors. In fact, guys, you can, if you want to add an extra information, all virtual images are laterally inverted as well. All virtual images are laterally inverted. Real images are not laterally inverted, but virtual images are laterally inverted. All right. Let me tell you why this. What is the significance of this later when we come to spherical mirrors. Right. So let's go on. Moving on, guys. Then let's start with the 1-marker questions. Now, people, again, the funda is very simple. I want you guys to be honest. Let me know in the comment section how many of you guys were able to clear all of the questions without any external help. Let me be honest. Let me know in the comment section how many of you guys were able to answer every question without any external help. When I say external help, no bhaiya, no behan, no mom, no dad, no Google G, no Google's, sister, Bing, no, nothing. All right. I think that's also a search engine. No, none of these. I want you guys to do it by yourself. All right. So here's the question. It's a 1-marker question, which means it's a 1-mark question. That's what it means. All right, here's the question. A ray of light is incident on a plane mirror at an angle of incidence of 30 degrees. The ray after reflection is deviated through what? Options are 30 degrees, 60 degrees, 90 degrees, or 120 degrees. Pause the video and let me know what is the answer. All right. But again, if you can't answer this, guys, I'm sure you'd have answered it, but still, let me answer this question for you people. The answer, guys, is going to be option number A. It's going to be 30 degrees, because according to the law of reflection, right, according to the first law of reflection, angle of incidence is always equal to angle of reflection. So whatever is the angle of incidence, angle of reflection will also be the same. Here, the angle of incidence is 30 degrees. That means that angle of reflection must also be 30 degrees. This is the first law of reflection. So quite an easy one. It's a 2-marker question now. Moving on to the 2-marker question, guys. Here's the question. An object is placed at a distance of 0.25 meters in front of a plane mirror. The distance between the object and the image would be what? The question is, guys, an object is placed in front of a plane mirror. So draw the figure first. So this is the object. Let's say it's a person who's standing at a distance of 0.25 meters. Simple. Now, what would be the distance between the object and the image? What would be the distance between the object and the image is the question. Now remember guys, in a plane mirror, if the object is 0.25 meters away, the image will also be 0.25 meters away. That's obvious. I'm guessing you guys have already put down the answer in the chat box, but still, it's going to be 0.25 meters away. But the question is, what is the distance between the object and the image? This distance is what they're asking. What is that distance? 0.25 plus 0.25, which makes it 0.5 meters. Voila. Super easy question, right? I hope you got it. If you did not get it, this is how you do it. I know that some of you guys would have directly said, sir, 0.25 meters out of excitement, but they're asking the distance between the object and the image here. So please make sure you look at these small details as well. All right, moving on, guys, moving on. Third question, it's a 3-marker question, assertion reasoning type. Now let me tell you one thing guys, even though here they've given it as 1 mark, 2 mark and 3 markers, in your board exams, all questions carry equal amount of marks, all right? There is no 1 mark, 2 mark, 3 mark and all. Every question carries the same amount of mark, all right? But yes, you can expect, you will definitely have assertion reasoning type questions. It's a very important one because again guys, this type of questions is where majority of the students go wrong in. So try your best, all right? Here's the question. Assertion is, incident light is reflected in only one direction from a smooth surface. The reason is, since the angle of incidence and angle of reflection are same, a beam of parallel rays of light falling on a smooth surface is reflected as a beam of parallel rays in one direction only. Options are, both assertion and reasoning are true or correct, and reason is the correct explanation for assertion. Both assertion and reason is true, but reason is not the correct explanation for assertion. Assertion is true, but reason is false. Assertion is false, but reason is true. What do you guys think? Think about it, guys. Think about it. I'll give you 10 seconds. Got the answer? The answer to this question, guys, would be option number B. Nah, option number A. Let me tell you why. Because guys, if you have a smooth surface, the type of reflection that happens over here is called as regular reflection. I'm pretty sure you guys remember this in your lower grades. You would have studied something called as regular reflection and diffused reflection. So this is basically called as regular reflection. Why? It's a smooth surface. So if a ray of light is parallel, if there are few rays of light that are parallel to each other, after reflection also they'll be parallel to each other. Why? Because the smooth surface. Now if the surface was irregular, then what you have is diffused reflection. What would happen is that, imagine there are 3 rays of light falling. One ray of light might go in this direction, one might go in this direction, one might go in a different direction. So this is called as diffused reflection. And that is something which would, which would be, again, they still follow the laws of reflection. They do follow the laws of reflection. There's nothing that, fundamentally they do follow the laws of reflection, but it's not going to be giving you a clear image. That's all, right? So the answer to this question would be option number A. Both assertion and reason are absolutely true, and reason is the correct explanation for assertion, because angle of incidence is always equal to angle of reflection. That is why here you see that they're all parallel to each other. All right, that's it. Moving on, guys. Now, let's talk about spherical mirrors. So we have done with plane mirrors. Now we are moving on to spherical mirrors. Now, what is a spherical mirror? First of all, why did we get the name as spherical mirror? Because this mirror is not a sphere. It doesn't look like a ball. It looks more like a curved surface. So why is it called as a spherical mirror? Because guys, a spherical mirror was basically a part of a glass sphere before. Before you cut it into pieces, it was actually a part of a glass sphere. Then what we did was that we cut a small portion of it and took out a curved mirror. Now here, depending on which side you decide to silver, you can either have a reflecting surface that is curved on the inside like this one, or you can have a reflecting surface which is curved towards the outside. If the reflecting surface is towards the inside, something like this, the reflecting surface is outside and the back side of this or the outer surface is silvered, this would be called as a concave mirror, caving inwards. On the other hand, let's say you have another mirror which basically looks like this. The reflecting surface is curved outside and the inner surface is silver. This would be called as a convex mirror. Simple as that. So you have a concave mirror, and then what you have is a convex mirror. That's it. Simple. Curved inwards, concave, curved outwards, convex. An easier way to remember this, because I'm sure a lot of you guys still have this confusion. So just an easier way to remember this, guys. Concave, caving inside, caving inwards. Convex, flexing outwards. Flexing outwards is convex. Simple as that. All right. Moving on, guys. Now there are few components or different parts that you have in a spherical mirror. Very important, because this is what is going to help you to do your ray diagrams. We'll talk about ray diagrams also, but before that, let's talk about the components of a spherical mirror. See guys, a mirror has different parts. The first part is called as the center of curvature. What is the center of curvature? It's nothing but, see guys, I told you that this sphere, from the sphere, I took a small portion. I cut a small portion and got my mirror, be it concave or convex. Now people, this sphere will have a center because it's a proper geometric shape. It'll have a center. The center of the sphere of which my mirror was a part of, or from which I took out the mirror, that is called as the center of curvature. Simple. Center of the sphere is called as center of curvature. That's it. All right. Now one more thing, guys. If it is a proper circle, if it's a proper three-dimensional circle, which is nothing but a sphere, it will also have a radius. It'll obviously have a radius. What is the radius? The distance from the center to any point is called as the radius. The radius of the sphere is called as radius of curvature. That's it. Center of curvature, radius of curvature. So if you see this, guys, if you have, this is my concave mirror, right? This is my concave mirror. This is the sphere. See this? Here's my center of curvature. And this distance from the center of curvature to the center of the mirror would be called as the radius of curvature. That's it. All right. Aperture is nothing but, guys, the entire reflecting surface. Just to give you an example, I think I must be having a spoon somewhere over here. Just give me a second, guys. Yes. Yes, because I've explained this so many times that I have to carry a spoon with me now. All right, look at this now. If you look at this very carefully, guys, you can see that images form from every single corner. Every single corner, light is falling and getting reflected and forming an image. So the entire reflecting surface, be it concave or convex, that is called as the aperture of the mirror. The entire reflecting surface is called as the aperture. Simple. That's all. 𝗘𝗺𝗃𝗃. After that, people, you also have to understand about pole and principal axis. What is pole is nothing but the center of the sphere. That's it. The center of the sphere. See guys, this is the mirror. The center of the mirror is called as the pole, which is nothing but the geometric center of the mirror, or the midpoint of the mirror, that is called as a pole. Finally, but definitely not the least, a straight line that is passing through the center of curvature and the pole would be termed as the principal axis. Now, why is this principal axis so very important? Because all of the distance that you measure, be it the object distance, be it the image distance, all of these distances you'll be measuring with respect to your principal axis itself. All right. So it's nothing but a straight line passing through the center of curvature as well as the midpoint of the lens or mirror, which is nothing but the pole. Right. That's it, people. Those are the different components of the mirror. So let's move on to the one-marker questions over here right now, people. Here is another question. The mirror having reflecting surface curved inwards is called as what? Curved inwards. Concave mirror, convex mirror, cylindrical mirror, or a plane mirror. What do you guys think? I'm sure you guys have already put down the answers in the chat box. I'll give you another 5 more seconds. In 4, 3, 2, 1. It's called as option number A. Concave mirror. Why? It's curved inwards, caving inwards. Concave mirrors are the ones that are caving inwards. So the surface that is curved inwards would be called as a concave mirror. As simple as that. Moving on, people. Moving on to the next topic. Now, people, what you need to understand is that if I have a concave or convex mirror, let's say there is a ray of light which is parallel to the principal axis. Can you guys see that? This is my principal axis right here. This is my principal axis. The straight line that is passing through the center of curvature and the focus, that's my principal axis. There is a ray of light which is parallel to the principal axis. It's almost parallel to the principal axis. Now here's what happens. That ray of light after reflection will basically cross or cut a point on the principal axis. It will just pass through a point on the principal axis. Or some point on the principal axis. Some random point. Let's say that I have another ray of light which is also parallel to the principal axis. Here's what's going to happen. That ray of light also after reflection will cross the same exact point that the one before did. That point on the principal axis where all these rays of light are meeting after reflection, that is nothing but the principal focus, or in simple words, focus of that particular lens or mirror. Wherever these rays of light are meeting after reflection, as long as they are parallel to each other, after reflection they will meet at a certain point on the principal axis. That point where they are meeting would be called as the focus of a concave mirror. Now, for convex mirrors also you have a focus, but here's the catch. In a convex mirror, the focus lies behind the mirror, not in front of it. Here, guys, if you look very carefully, the focus is in front of the concave mirror, but in convex mirror, the focus lies behind the mirror and not in front of it. Quite tricky, but it's actually quite simple, because here's the thing, guys. In a convex mirror, a convex mirror is basically a diverging mirror. Diverging mirror means it's like it doesn't want these rays of light to meet. All right, it doesn't want them to meet at all. It's like your your parents in games. It's never like none of your parents would encourage you to play games. So they always wanted to keep away from games. It's like that. All right. So these convex mirrors are also like that. They're trying to keep these light rays away from each other. So what happens is this: there's a ray of light parallel to the principal axis, but after reflection, this ray of light is going to diverge away from each other. They're going away from each other. And here's the catchy part, people. Let's say there is a person standing over here and these rays of light are falling into his eyes. Right? I know that's not going to happen to that ray of light, but yes, imagine that it's falling into your eyes. All right. It does not mean that light is going to, do like bend it like Beckham and, go and fall into his eyes. I'm just giving you an example. Here's what is going to happen. His eyes or your eyes, when you're trying to trace back the source of this light, it appears as though these rays of light are appearing to come out, or appearing to, merge at a certain point. They're appearing to, originate from that particular point, one particular point behind the mirror. That is called as the focus. So focus for a convex mirror lies behind the mirror, but focus for a concave mirror lies in front of the mirror. Got it? So that's pretty much all the nomenclature that you must remember. Now the distance from the focus to the pole would be called as the focal length, and the distance from the center of curvature to the pole would be called as the radius of curvature. One very important relationship between radius of curvature and focus is that your focal length is always for a mirror of smaller aperture. For a mirror of a smaller aperture, that is a mirror with smaller reflecting surface, the focal length is going to be half the radius of curvature. Whatever is the radius of curvature, half of that will give you the focal length. This has been proved mathematically, and in your higher grades, when you go to your 11th and 12th, you'll also be studying the derivation for this one as well. When you go to your 11th and 12th, when you have this light chapter once again, you're going to be studying the derivation. How did they come to this conclusion? You'll study that in your higher grades. For now, for 10th standard, you just need to remember this formula: F is equal to 1 by 2 into R, or R is equal to 2F. That is nothing but your radius of curvature is twice the focal length. Simple. All right. So I'm going to ask you a question based on it now. All right. Now, people, let's do this question and then we'll come back to the topic. Here's the question. Radius of curvature is found to be equal to twice the focal length for which? For plane mirrors of small aperture, spherical mirrors of small aperture, plane mirrors of large aperture, or spherical lenses. For which of these radius of curvature is equal to twice the focal length? Super easy question. I know you have already put down the answer in the chat box, but still I'll give you 5 seconds to think, to go back to the answer that you gave, and if you want to change the answer, you still have that option. I'll start the quiz in I'll tell the answer in 4, 3, 2, 1. The answer is going to be option number B. It's a spherical mirror with smaller aperture. Right, guys? Let's get back to the topic now. Now, guys, here's the thing. You have certain ray diagrams that you need to understand in this chapter. One of the most important concepts in this chapter is the ray diagram. That ray diagram is super duper important, not only because they might give you ray diagrams, but also for your numericals. You can use those ray diagrams to cross check your answers. In fact, even sometimes you can even do or solve the numericals with just the ray diagrams. I'll tell you how in the sessions ahead, but let's talk about this one now, guys. See, people, you can have n number of rays. You can have n number of, rays falling on the mirror and, forming the image. You can do that. But the problem is that, let's say there's a ray of light which is coming and falling at this angle. All right, this is my mirror and it's falling at this angle. Now, the problem is that you have to find out what is the angle of incidence. You have to find out what is the angle of reflection. You have to, use a compass and all of that. And then, make sure that these rays of light are meeting at a certain junction. You have to do a lot of things. But in order to make your lives a lot more easier, guys, you can do, or you can go with the standard incident rays. So the standard incident rays are not the only rays of light. Let me remind you, these are not the only rays of light, but these rays of light that you're taking would make it 100 times more easier in order for you to solve these questions. So what are these standard incident rays? There are 3 standard incident rays for concave as well as convex mirror. The first one is if a ray of light is parallel to the principal axis. Remember, if a ray of light is parallel to the principal axis, after reflection, it is going to meet at the focus, or it's going to pass through the focus. This is your first standard incident ray. And trust me when I say this, guys, you are going to be using this for every single ray diagram. Every single ray diagram for concave mirrors, you're going to be using this. So please do not ignore this. A ray of light parallel to the principal axis, after reflection passes through the focus. Second one is, if a ray of light is passing through the focus, then after reflection, it becomes parallel to the principal axis. In other words, it's vice versa. Vice versa the first one. If it is parallel, it's passing through the focus. If it's passing through the focus, then after reflection, it becomes parallel to the principal axis. And finally, a ray of light passing through the center of curvature after reflection will get reflected back in the same exact path. Let me tell you why. Because, guys, if let's say this is the ray of light and this is incidenting at that point. If I want to draw normal to that point, I have to basically draw a straight line from the center of curvature to that point. That is my normal. Now here, if a ray of light is passing through the normal, then what is the angle of incidence? 0 degrees, right? Because it's not forming any angle at all. The ray of light is incidenting exactly at normal, 0 degrees. So angle of reflection will also be 0, which means that it will get reflected back in the same exact line. That's it. Okay, guys. For convex also, it's pretty much the same, but there's a little difference here because, again, the center of curvature and focus lies behind the mirror. So the rays of light can't really go through the focus or can't really go through the center of curvature. So it's going to be slightly modified over here. Again, it's pretty much the same. A ray of light parallel to principal axis after reflection appears to pass through the focus. It doesn't actually pass through the focus. It appears to pass through the focus. A ray of light which is passing through the focus or appearing to pass through the focus after reflection becomes parallel to the principal axis. And finally, a ray of light passing through the center of curvature or appearing to pass through the center of curvature here, it gets reflected back in the same path. So the only add-on is that here you have to use the word appears to. It is not actually doing so. So because that, you have to add in that extra term called as appears to. All right, moving on, guys, moving on to the next question. Here's another one. It's a 2-marker question. The question is, the focal length of a concave mirror is 10 centimeters. Find the radius of curvature. I mean, yes, very difficult question. Go ahead. Is it 25 centimeters, 5 centimeters, 10 centimeters, or 20 centimeters? I'm pretty sure you guys have already put on the answer. Let me just drink some water in the meantime. The answer is going to be 20 centimeters, guys. Why? Because focal length is twice the radius of curvature. That means it's 2 into 10 because the focal length, your radius of curvature is twice the focal length. Sorry for that. Radius of curvature is twice the focal length. So it's focal length is given as 10. So 2 into 10, you'll get it as 20 centimeters. That's it. All right. So that's a 2-mark question. Done and dusted. Moving on, people. Moving on. Now this is where a lot of you guys have problems in. Now guys, I have done a separate video for ray diagrams for concave as well as convex mirrors. Please do check it out. Trust me, you're going to find it super duper easy. Trust me, it's that easy. But yes, I'm going to quickly take you through it one more time because it's let's revise, no? So I'm just going to quickly revise everything. Now, there are 6 object positions for which we are going to get 6 different image position and 6 different image properties as well. Now, these object positions are when the object is at infinity, when the object is beyond C or between infinity and C, when the object is at C, between C and F, at F, and between F and P. So these are the 6 conditions for which we're going to be doing the ray diagrams. So I'm just going to quickly show you what the ray diagrams looks like. These are those 6 ray diagrams. When the object is at infinity, we are only taking those rays of light which are parallel to each other. All right. When the object is at infinity, it's not that all rays are parallel. We are taking only those rays of light which are parallel to each other. So when they are parallel to each other, after reflection, you can see that they would be meeting at the focus. So the image formed when the object is at infinity is going to be at focus itself. And if you look at the size of the image, it is highly diminished. It is a point-sized image. In fact, it's a point-sized image. It is real in nature, and it is also going to be inverted because all real images are inverted in nature. Second one is when the object is beyond C or between infinity and C. In this case, guys, after reflection, one ray of light parallel to principal axis, one more passing through the center of curvature, and these two rays of light are meeting at a junction between C and F. So that is where the image is formed. And if you look at the size of the image, it is diminished, absolutely, because it's smaller than the size of the object. It is also going to be real, and it is also going to be inverted in nature. So this is the image property for the second one. For the third one, when the object is placed at the center of curvature, the best part over here is, guys, the image will also be formed exactly at center of curvature itself. Nowhere else. It will be formed at the exact same position. Again, one ray of light parallel to principal axis, one more passing through the center of curvature, and they're meeting at a point exactly at C, at the center of curvature. And if you look at the size of the image, it is of the same size, because if you look at it, the size of the object and size of the object image is exactly the same. It is going to be real, and it is also going to be inverted in nature. Next one is when the object is placed between C and F. In that case, the image is going to be formed beyond C. And if you look at the size of the image, it's going to be magnified or enlarged in nature. It's enlarged, real, and inverted. Moving on, people, we also have object placed at the focus. When the object is placed at focus, the image is going to be formed at infinity. Let me tell you why. Because if you take these two reflected rays, you see that one ray of light parallel to principal axis, after reflection passes through the focus. One more is passing through the center of curvature. But where are these two rays of light meeting? They are almost parallel to each other, right? So we are assuming that these rays of light are meeting at a point very, very far away, which we'll call it as infinity. That's all right. And if you look at the size of the image, it's going to be highly magnified or highly enlarged image. Here also you're going to get an enlarged image, which is real and inverted in nature. Finally, last but definitely not the least, is when the object is placed between focus and the pole. When the object is placed between focus and pole, in that case, people, the image is going to be formed behind the mirror. This is the only condition in a concave mirror. Mark my words. This is the only condition in a concave mirror where the image is going to be virtual, enlarged, and erect. In other words, the virtual, erect, and enlarged. Simple. This is the image, because the image, if you look at it, is formed behind the mirror and not in front of it. It's formed behind the mirror, and hence, guys, it's virtual, enlarged, and erect. That's it. Voila, people. Then this is your entire table. Please do take a screenshot of this one. I've already mentioned it, but yes, you can please take a screenshot of this one if you want to, and try to refer to it whenever you want. Moving on, guys. Then we have ray diagrams of convex mirror. The thing about convex mirror is that it is so nanna munna, because there are only two ray diagrams on a convex mirror. That's it, just two. One, when the object is at infinity. Second is anywhere in front of the mirror. Does not matter wherever you keep it. You're always, remember guys, in a convex mirror, you're always going to get 𝗲. When I say 𝗲, I'm talking about virtual image, always erect in nature, and it is always diminished in nature. In the case of a convex mirror, people, the image will always be virtual, erect, and diminished. As simple as that. Alright. So this is what the ray diagram looks like. One ray of light parallel to principal axis, after reflection, appears to pass through the focus. One more ray of light is appearing to pass through the center of curvature, and these two rays of light are meeting at a point between the pole and focus. No matter where you keep the object, the image in the case of convex mirror will be formed between the pole as well as the focus. That's it. All right. Okay. I think that went all the way to the last page. Let me just quickly, I don't know what that was all about. That's like magic. Just give me 1 second, people. Let me just go back to that slide. All right. Yes, here we are. All right. So that is it, guys. So that is Vedantu's 𝗲. Just remember it like that. Virtual, erect, and diminished. That's it. And yes, guys, this is what the image properties are. When the object is at infinity, image is going to be formed at focus. It's going to be diminished, erect, and virtual. When the object is anywhere in front of the mirror, the image is going to be formed between pole and focus. It's going to be diminished, erect, and virtual. Simple. Right, so those are the ray diagrams of concave and convex mirrors. Very important, but also if you look at it, if you just remember your, your standard incident rays, it's actually quite simple to do it as well. You don't have to by heart all of this. It's actually quite easy. Moving on, people. Now, the next thing you must know is the sign convention. Now, why is this so important? Because sign convention, if you get it wrong, trust me, people, your numericals are going to be super, super, super messed up. Make sure you remember your sign conventions. Let's say I have a concave mirror. All right. Now, remember this, guys. Your sign convention is quite simple. Now, in your lower grades, you have probably studied about Cartesian planes, right? In Cartesian planes, if you remember, this is x dash, this is x-axis, this is x dash, this is y, and this is y dash. Now, all distance towards the, towards the right-hand side from the origin, you take it as positive. All distance towards the left-hand side, you're going to take it as negative. And all distance above the origin, you take it as positive. This distance, you'll take it as positive. And below the origin, you take it as negative, right? Y dash is negative, y is positive, x dash is negative, and x is positive. The same thing, do it over here also. The same thing. If this is my mirror, imagine this is my, the pole is basically my, the origin here. All distance in front of the mirror, you're going to take it as negative. All the distance in front of the mirror will be taken as negative. All distance behind the mirror, you'll take it as positive. All distance above the principal axis, you'll take it as positive. All distance below the principal axis, you'll take it as negative. So in other words, guys, in a concave mirror, the focus is always negative. The radius of curvature will always be negative. The object distance is always going to be negative. For concave mirrors in particular, the focus and radius of curvature will always be negative. But for convex mirror, it's going to be a little different. The focus is going to be, the focal length is going to be positive. The radius of curvature will also be positive, but the object distance will still be negative because we always keep the object on the left hand side. Be it mirror, be it lens, does not matter. We are following a standard way of doing things. That is why we always keep the object towards the left hand side. So object distance will always, always, always be negative. Simple as that. Alright guys, so those, my friends, are your sign convention. Very important for your ray diagrams and also for your numericals as well. Alright, so let's do another question, people. Here is another 1 mark question for you guys. Which of the following image can be formed by a concave mirror? Options are real inverted and enlarged, virtual upright and enlarged, real upright and reduced, or virtual inverted and enlarged. Options are 1 and 2, 1 and 3, 2 and 4, or 1, 2 and 4. Let me know in the chat box, guys. Let me know in the chat box. I'm pretty sure some of you guys have already answered it. But yes, for all the others, take your time. But let me know what is the answer, all right? Which of the following image can be formed by a concave mirror? Quite simple, because we know that a concave mirror can form real images, virtual images. It can be erect, it can be inverted, it can be diminished, it can also be erect. But here's the thing, guys, like I told you before, if you remember the love story, real images are always inverted in nature. All right, this is a pure love story. Real images are always inverted in nature. Virtual images are always erect in nature. Virtual are always erect. Real are always inverted in nature. If you look at option number 3 and 4, no, it says real and upright, which is erect, which is not possible. So third cannot be the right answer. And the fourth one also says that virtual image, but it's inverted. Virtual images are always erect. So third and fourth is definitely not. So then what are the other options left out? Real images are inverted. You can form real, inverted, and enlarged image. You can also form virtual, erect, and enlarged image. That is when the object is placed between pole and focus. So the answer to this question would be option number A. That's it. This is called as the elimination method. This is one way to do your, in your exams also. If you want, you can follow this method where you eliminate out the answer that you know is wrong. Then figure out which is the right answer. All right. Moving on, guys. Moving on to the next question. Here is another one. If the image formed by a mirror for all positions of the object placed in front of it is always virtual, diminished, state the type of the mirror and draw any ray diagram to support your answer. Options are concave, convex, and cylindrical, or plane. Trust me, guys, it cannot get any easier than this. It cannot get any easier than this. If the image is formed by a mirror, it's always virtual and diminished. Which type of mirror is that? Direct answer, convex mirror. Don't even have to think about it's convex, because convex mirrors are always Ved, always virtual, erect and diminished. Vedantu's Ved, that's it. Now people, to draw the ray diagram. It's quite simple, but let me try to do my best, alright? Again, please don't judge me because I have a very bad drawing skill. So please don't judge me. So this is a concave mirror, right? This is a convex mirror right here. So this is my object, alright? This is my pole right here. I'll call it as P. Let me just mark with a different color so that you can differentiate it. So I'll call this as P. I'll call this as my focus. I'll call this as my center of curvature. I'm going to take one ray of light which is parallel to the principal axis. All right. After reflection, this ray of light will appear to pass through the focus. I am going to take another ray of light that is appearing to pass through the center of curvature, which is appearing to pass through the center of curvature. After reflection, this ray of light will get reflected back in the same path. Now, where are these two rays of light meeting, people? They are meeting at a junction between P and F. So the image will be formed between P and F. That's all. One ray of light parallel to principal axis, after reflection appears to pass through the focus. One more ray of light appearing to pass through the center of curvature. After reflection, it will get reflected back in the same exact path. So that would be your ray diagram. I know it's a very vague ray diagram, but I'm pretty sure you guys can make it out from this one. So this would be a ray diagram as well, guys. All right. So that is the answer for that question, which is nothing but a convex mirror. Now, before we get into the next question and call it a day, let me tell you something very important. Something that has a potential to change not only your life, but your parents' life, your family's life forever. Yes, guys, I am talking about the Vedantu's foundation courses. Now, these foundation courses are not just for your 10th standard exam. These foundation courses, this is for your JEE preparations, your entrance exam for your medical, that is your NEET preparations. This is an exam which prepares you from a very young age to attempt those kind of competitive exams. But it doesn't just end there, people, because these foundation courses not only offers you your foundation batch, which is nothing but your basic foundation for your NEET and JEE examination, these competitive exams, but also gives you an opportunity to study all of the CBSE courses, both term 1 and term 2, both term 1 and term 2, both of them included with this foundation courses. And not only that, people, it doesn't just end there. With this, you will have NTSC preparations. You will also have Olympiad preparations, all for the same exact price. The same thing. Everything included in one single package. Trust me, guys, it does not get any better than this. Foundation plus CBSE term 1 and term 2, NTSC, Olympiad. Which institute would give you that? NTSC alone would, other people would charge you like 15,000-20,000. All of that together, one whole year of your JEE preparations, which would make sure your foundation, your basics are very strong, including CBSE, including NTSC, including Olympiads. It does not get any better than this. And yes, all the basic features of Vedantu that you guys already know of is already present. Engaging and interactive learning, deep understanding of the concept, continuous doubt solving with not only one teacher, with the class teacher and the Vedantu Doubts app as well. Both of these is going to help you to ensure that all of your doubts are cleared. Efficient time management sessions. You would have a very strong foundation of all the topic. Regular practice, regular tests and assignments, and yes, you are also giving yourself an opportunity. You're giving yourself a chance to make your life better, because trust me, guys, if you're able to clear those kind of exams like JEE and NEET, that would change your life completely forever. And this is an opportunity to do exactly that. All right, all of the topics, physics, chemistry, bio, English, and mental ability test and SST as well, everything would be included. Unlimited in-class doubt solving, NTSC preparations with exam strategies, which would help you to do these exams perform much better. So if you are an aspiring engineer or an aspiring medical, trainee, whatever it is, doctor, you want to be another doctor, this is your chance to feed that dream from now itself. Don't just let it be a dream. Don't just let it be a dream, because if you wished for it, make sure you start working for it. And this is an opportunity for you to start that exact thing. And don't forget about Vedantu's improvement promise. This is always going to be there. This is that chappa, this is that guarantee that yes, your scores would improve. At the end of the year, if your scores do not improve, you can get your complete fee back. Without any questions asked, you can get your complete fee back as well. That is Vedantu's improvement promise. Without that, people, you never know. But yes, Vedantu's improvement promise is always there with you guys. These are the kind of results that we have passed. This year, 547 students have qualified for JEE Advanced. That's a very, very huge number, with about 29 students getting 100 percentile in physics. And again, I am talking about one of the toughest exams in the world. Students are scoring 100% percentile, which is definitely not a small deal. I'll just quickly show you how to enroll into these courses, guys, so that you get a better idea of how to do it, all right? So yeah, I'm just going to quickly show you how to join these courses. So basically, guys, go to Vedantu 9th and 10th English. Yes, Tangu. Tangu. All right, so what you do is, guys, go to the video, whichever video it is. So yeah, this is I think a couple of days ago there was one of the videos that came out. So this is one of the videos that came out. So what you do is, guys, go to the description of this particular video, go to show more. Once you click on show more, people, you have an option called as exciting Vedantu courses. Just click on this and it will directly take you to the web page. Now what you do is that click on change over here and go to NTSC course or go to foundation, 1 year foundation course. This foundation course, guys, like I told you, would be taught by the best of the best educators. And I'm talking about people with up to 20 years of experience, 15 years of experience, who have produced amazing results in NTSC and Olympiads in the past years. Those are the kind of qualified teachers you're going to be getting in these batches. And yes, guys, the 1 year program for this entire thing, everything, term 1, term 2, NTSC, Olympiad, everything together is 25,200 rupees. I know it's a lot of money, because we are all in Indian middle class. We understand that it's a lot of money. Don't worry, guys, because you have the EMI option where you just have to pay around 2,100 rupees per month. That 2,100 rupees is just if you go to a showroom and buy a shirt or a pant, that itself would cost you more than that. That's how much you're paying for your life, for your education, to get a better life. That's how much you're paying. And yes, guys, if you want to try the 1 month program, you can go with that also. The 1 month program is 2,550 rupees. And this is Vedantu Lite. The difference is that there are few key features that are different. In Vedantu Classic, you also get the Doubts app. You also get the Vedantu's Doubt app, where you can get your doubts cleared anytime you want. Vedantu Pro Plus will have that also, and you'll have a personal mentor. But the price of it is a little high. It's on the higher end, right? But if you have money problem and you know that your parents can't really afford it, because obviously, guys, when I was a student, I couldn't just ask for 25,000 rupees. My parents wouldn't have agreed for it. I totally understand it. Sit with them and talk to them and make them understand that it is for your 1 year program for just 2,100 rupees for all of the 6 subjects, for your NTSA preparation, CBSE preparations, and including all of this Olympiad preparations as well. For that, it's a lot less. You'll also get mental ability. You'll also be getting SST preparations. So everything is included in this one single super duper amazing chota packet bada dhamaka. So yes, guys, it's all right there. Again, automatically 10% discount is automatically added as soon as you click on the link that is given in the description. If you don't want to save money, then don't have to use my coupon code. But if you want to save some money, you can also use my coupon code and get 10% discount as well. So after discount, this would come down a little bit more. You can check that out once you log in. All right, so you can check that out as well. All right, guys, so those are the Vedantu's courses. Again, I would really request all of you guys to think about it if you are still in the verge of deciding, when to start your revisions, or you're still deciding of what is it that you really want to do in your future. This is an opportunity for you guys to get a path. to get a path so that from now on itself you start correcting yourself rather than wasting a lot of time. Because even I have a lot of, I wish someone had told me to, start preparing for JEE from my 10th standard. But nobody in my family, neither did my teachers ever talk about it. I don't even know about JEE until I crossed 12th standard. So that is the kind of friend circle that I had. That is the kind of, environment that I have. But you guys have an opportunity to see everything beforehand, so you understand how life is, how it's going to be in your future as well. And that is what we are offering you here. It is not just a course, it is a way to change your entire life. Right, guys, these are the dates that the courses are going to be starting. 11th of October is the next foundation batch that is going to be starting in just a couple of days. Again, guys, you don't have to go for the entire year-long program. Go with the 1 month program for 2,340 rupees or whatever it is. Just try that. Try the 1 month program. Anyways, it's not going to be wasted, because you'll get term 1 preparations, which is going to be happening in the next 40 days. You'll also get term 2 preparations once it's done with that. Olympiad preparation, NTSA preparation, which is going to happen in November. Everything is included. So it's not going to be it's definitely going to be wasted. So you're going to, get the best out of that even in that 1 month as well. Alright, guys. So that's it for today. That's it from my side. I hope you enjoyed it. I hope you learned something new. I hope that all of you guys are taking your exams a little bit more seriously. And I hope you guys have started with your revisions. And if you haven't done it yet, it's still not too late, people. You still have 40 days left, to be precise. Maybe less than that, maybe up or down a couple of days. But yes, about 40 days is what you have. So in that 40 days, try to make sure that you complete these 2 chapters. There are only 2 chapters in physics. And trust me, these chapters are quite simple. It just requires a little bit of attention. If you are feeling any of the topics to be hard, the entire playlist is right here. If you just go to the description, you can see the entire playlist, the MCQ wala playlist, case-based study, the Prodigy series for both physics, chemistry, biology. Everything is right there. SST for all of that is right there. Just go to that, click on that link and check out all of the videos. Let me know in the comment section how today's session was. Let me know, by the way, how today's background also is, because I'm trying out something new. Let me know that also in the comment section, and let me know if you guys were able to answer all of the questions in today's session. All right, catch you guys in the next session, guys. Until the next time we meet, I hope that you guys would have become a little bit more better the next time we meet. Until then, take care of yourselves, stay safe, have a great day ahead. Peace out, people. Catch you guys soon. Bye bye. Take care.